Welcome back. Today, we're diving into the brain of the hydronic heating system, the controls. You can have the best boiler and the most expensive piping, but if the control strategy is flawed, the system will never deliver comfort or efficiency. We're going to break down how we tell water where to go, how hot it needs to be, and when to get there. Let's start with the absolute basics, the closed-loop control system. It sounds technical, but it's just a cycle. You have a sensor that measures something, like room temperature. It sends that info to a controller. The controller compares it to what you want the temperature to be. If there's a difference, an error, it tells a device, like a valve or boiler, to do something about it. Then the sensor measures the result, and the loop starts all over again. In control theory, the magic word is error. Now, don't panic. Error doesn't mean something is broken. It just means the difference between where you are and where you want to be. If your thermostat is set to 70 degrees and the room is 68, you have an error of 2 degrees. The controller's entire job is to drive that error to 0.
How does the controller decide how hard to react? That's the algorithm. The simplest is proportional. If the error is big, the reaction is big. Integral looks at how long the error has existed, helping to fix long-term drift. And derivative looks at how fast the error is changing, predicting the future. Put them together, and you get PID control, the gold standard for smooth, accurate heating.
Now, think about how we deliver heat. The old school way is on-off, like a light switch. It's either full blast or nothing. This works, but it causes temperature swings. The modern way is modulating control. Think of a dimmer switch. We can ramp the boiler up or down to match exactly what the house needs. It's smoother, more efficient, and much easier on the equipment. One of the most important concepts you'll learn today is outdoor reset. Here's the logic. Why run your boiler at 180 degrees when it's only 50 degrees outside? You don't need that much power. Outdoor reset automatically lowers the water temperature as the weather gets warmer. It's like cruise control for your heating system, saving fuel and keeping the house consistently comfortable. This relationship is defined by a reset ratio. Different heat emitters need different curves. A radiant floor might need a gentle curve because it uses low-temperature water. Old cast-iron radiators might need a steeper curve. Setting this ratio correctly is what separates a pro from an amateur. We can control heat output in 2 main ways. 1, keep the flow constant but change the water temperature. That's what outdoor reset does. 2, keep the temperature constant but change the flow rate, like using a zone valve to stop flow when the room is warm. Both work, but variable temperature is generally smoother and more comfortable. To make all this hardware talk to each other, we use ladder diagrams. It's the standard language of control wiring. The vertical rails are your power, and the horizontal rungs are your circuits. If you can read a ladder diagram, you can troubleshoot almost anything. If you can't, well, you're just guessing. The building blocks of these diagrams are switches and relays. A relay is just a switch that is operated electrically rather than by your finger. You energize a magnetic coil, click, and the contacts close. This lets a tiny 24-volt thermostat signal turn on a massive 120-volt pump. It's essentially a remote-controlled switch. When we zone a building, we often use zone valves. The most critical part of a zone valve isn't the motor, it's the end switch. This is a little switch inside that tells the boiler, okay, I'm fully open, you can fire now. Without that feedback, you might fire the boiler against a closed valve, which is not good. Here is a critical safety concept, boiler protection. If you send cold water from a radiant floor directly back into a standard non-condensing boiler, the flue gases will condense into acid and eat the boiler alive. We use mixing valves to blend hot water back into the return, keeping the boiler hot enough to stay safe. One elegant way to handle mixing is injection mixing. Instead of a big 3-way valve, we use a small variable speed pump to inject just enough hot water into the system loop to hit our target temperature. It's precise, efficient, and protects the boiler. It's basically using a pump as a valve. Sometimes you don't have enough power to do everything at once. That's where priority control comes in. Usually, making hot shower water gets priority. If someone needs a shower, the system pauses the heating for the house for 20 minutes to focus all energy on the water tank. The house won't cool down in 20 minutes, but a cold shower is noticed immediately. So to wrap up, controls are the brain of the operation. We use closed loops to fix errors, outdoor reset to maximize efficiency, and mixing strategies to protect our equipment. Whether you're using simple relays or networked web-enabled computers, the goal is the same: deliver the right heat at the right time to the right place.